Today's video lesson is about rounding with significant digits. Now, when we round with significant digits, we can round to a specific place value, or we can round a measurement to a specific number of significant digits. Generally, rounding to a specific place value is done when we add or subtract measurements. We round to a specific number of significant digits generally when we multiply or divide values. When we round to a specific place value, there are some things that you have to be aware of. First, some of what you learned in elementary school isn't going to serve you very well. When you learned how to round in elementary school, you usually started at the very last number, and let's say it was a 5, you rounded the number right before it up, and then if that caused the number to be greater than 5, you rounded up, and you kind of went all the way through until you got to the end. When we round in measurements in science, we only look one number past where our last significant digit is, and then we use that value to decide whether we round our last number up or we leave it the same. So I'm going to give you some examples and work through some problems. So first I have the number 45,978,513, and I want to round to the hundreds place. So I want to round where my 5 is. That's where I want my last significant digit. So what I do is I look one number past to see if that is going to cause my value to round up or stay the same. And what you have to remember, the general rule is if the number after is 5 or greater, you round up. And if the number is 4 or less, we tend to leave it the same. Okay, so when we look one number past, the next number is 1. So that's going to cause the 5 to stay the same. But the answer is not just 45, it's not just 4, 5, 9, 7, 8, 5, because what that does is it changes the value or the magnitude of the measurement. So what we have to do is we have to put in zeros to keep the number as big. So we replace these digits that we're getting rid of or rounding with zeros because we need to keep it at 45 million. And if not, we've decreased the value of it. So the second one is round to the 10,000ths place. So we have tenths, hundredths, thousandths, 10,000ths. So the 9 is in the 10,000ths place. So again, you look one number past, that's the 4. The rest of these don't matter when I'm rounding because they're not going to impact the outcome. So I look, and the 4 is not going to cause the answer to change or cause the 9 to round. So my answer is going to be 0.0159. I don't have any of the rest of the values because I've rounded them off. If I were to put them in, that would mean I was going more significant digit places. All right, the next value is 789,415, and I want to round to the thousands place. So I want to round where the 9 is. Again, I'm looking here at the 4 to see if it causes rounding of the 9. It does not, so I'm going to write that, but 789 is not the same as 789,415. So what I'm going to do, again, like with the first one, I'm going to put in 3 zeros to keep it at the same magnitude. I just am saying those values are not significant. Do not put a decimal because that would trap the zeros and change where the last value is or the estimated value. All right, now the last one, I picked one that's a little bit tougher. And you might say, well, to the tens place, that's not a big deal. So my 9 is in the tens place. And I look at my next number, which is 8, and that's going to cause it to round. But if I'm rounding a 9, that's going to cause rounding there. So what happens in this, because the 9 is going to change to a 0, and the 3 is going to change to a 4, but I need to make the 0 count. This value has to go in scientific notation. So let me write what it would look like without putting it in scientific notation. So 699, 818, and then 400. But that makes it look like my last significant digit is in the hundreds place. I don't want it in the hundreds place. I want it in the tenths place. So the only way to make this 0 count is to put this value in scientific notation. And we end up with 6.9981840. That allows us to catch the 0. And then it would be to the times 10 to the 8th. Now, when we multiply and divide, we round to a specific number of significant digits. And this is generally easier than rounding to place values. So I have the number 345,678, and I want to round to 3 significant digits. So because this is a number greater than 1, these are the digits that I'm looking to count. And again, I look one place past to see if it causes rounding. It does. The 6 is going to cause the 5 to round. So it's going to be 346. But again, I need to keep it as big. So I'm just going to replace those last few values with zeros to keep the magnitude the same. You could always take your value and put it in scientific notation before. And then what you can do is look at your first digits there. Look here and see if it causes rounding, and it does. And you could put your answer at 3.46 times 10 to the 5th. And that usually helps keep track of the missing place values, which we tend to forget. So now the next one, I have a number that is less than 1. And again, you could start by putting this in scientific notation. So we would have 1.2583 times 10 to the negative 4. And I only want 2 digits, so I want the 1.2. I look at the 5. The 5 is going to cause rounding. So my answer would change to 1.3 times 10 to the negative 4. Or I can leave it in standard notation. I can look, I don't need the 8 and the 3 because they're beyond my first 2 significant digits. My 5 is going to cause rounding, so I'm going to have 0.00013. And either one of those answers work. And again, same with this last one, you can put it in scientific notation, or you can leave it in standard notation and then just put zeros in as placeholders. So if I put it in scientific notation, I have 8.47374,338,374. That's a lot of numbers. Times 10 to the 3, 6, 9, 10, 11. I only want 2 digits, so I'm looking right there. The 7 causes rounding. All of these other numbers become unimportant, and my answer changes to 8.5 times 10 to the 11. Or if I left it in standard notation, again, I only really need these first 2 digits. The 7 is going to cause the rounding, and I would write 8, 5, and then replace all of the rest of the values with zeros. So I'm going to put in 10 zeros. 2, 3, 4, 5, 6, 7, 8, 9, 10. Generally, when you have numbers that are very large like this, we tend to put them in scientific notation because what happens is as we're writing all of those values, we tend to get kind of sloppy sometimes, and we just start putting them together, and then you don't know whether you have the right number of zeros or not. So the choice is yours. I prefer scientific notation because then at quick glance, I know what the answer is. So now your turn. This first section is I want you to round to the specific place value. So in the first one to the hundreds place, the second one to the 10,000th place, and the third one to the 10 millions place. It would make sense to pause the video at this time, write these down, and then you're going to submit these on a Google Doc with the second part of your work here. The second part of your work is to round to a specific number of significant digits. So in the first one, I want you to round to 4 significant digits, and the second one to 5 significant digits, and then the third one to 4 significant digits. Add these on as a continuation of your previous problems and submit them all on a Google Doc. This is your work for the day. This is also your check-in for the day. This needs to be submitted by midnight or 11:59 this evening. Have a great day.